All right, you guys, here we go with some new information in regards to the characteristics or properties of parallelograms. I'm going to demonstrate a little bit here on this one, and then I'm going to give you guys the rules that show what would be in the book. Okay, so I'm going to go ahead and draw a line here. Now, what we're going to do is we're going to talk about what are called the diagonals of a parallelogram. So I got my pen here. And what I'm going to do is I'm going to try and draw a straight line as much as possible, going from C all the way down to A. Okay, here's the characteristics. So I'm going to draw this as best as I can. If there was a mechanism that I could do to make it work better, then it would be good. So I draw a diagonal from C to A, and as we did in 6.1, we are creating by drawing diagonals to ones that are non-consecutive sides, is that we created two triangles. Okay, I'm going to tell you right now that this triangle is going to be congruent to this triangle here if we were to do that. Okay, so what that means is, let me go ahead and get what I'm talking about here. So we're going to grab, and I'm going to do some colors here. So we'll do this. So we know that these symbols right here mean that they're parallel. So opposite sides are parallel. This one means this side's parallel to that one too. But we also know that this side is congruent to this side. Okay? And we know that this side is congruent to this side. And then, because we have two attaching triangles with a common side between the two, we could say that this is congruent to each other by what, remember, was called the reflexive property. So we could sit there and say that all three sides are congruent, and from last semester we did it by side, side, side. That's how we would know that these two triangles are congruent. Okay, so that's one property that we need to know when we take one diagonal. Now, if we go next to this one here, and I'm going to draw a diagonal going from B all the way down to, and as you notice, my wonderful straight line, if I had a ruler on there, I could do it too. Let's see if we can do that a little bit better in this case. So I'm going to sit there and go, okay. Not much better. Okay, anyways, so we got this. So what happens now is this thing will get to a point where it intersects at. So let's do a different color. Let's go purple here. Okay, so this point of intersection right here basically does something here. And what it's going to do, where they intersect at, that means that the diagonals are going to bisect each other. So I'm going to write that up here. So I'm going to say, whoops, sorry about that. Diagonals bisect. Hold on a second. Bisect each other. Okay. So what that means is that this side is congruent to this side. Okay. So if this was a length of, let's see, 12, this length would also be 12. And that also means that this side is going to be congruent to this side. So this one is, let's say, 16. That means this side is also going to be 16. So that's one more characteristic that we're talking about. So again, let's review this. So we have, when we take one diagonal of the triangle, okay, cuts into, I mean, of the parallelogram, it cuts into two triangles. And these two triangles are going to be congruent by what is called the side theorem. Okay, because we know opposite sides are congruent, and then the one diagonal is congruent because it's of the reflexive property. Okay, so those are the two things that we're going to be talking about there. So if you have any questions about any of this stuff, this is what we will discuss in class if you're not sure. All right, hope that helps.